Okay, question 4. Given C is -2 and 0 is the center of the circle, points A, 0, -3, B, and D lie on the circumference. F is a tangent to the circle at A. Alpha and theta are shown. Right, so when you're reading these questions, you need to look for keywords and try to identify what's going on with those keywords in the diagram. So C is the center of the circle. When we're given a center, we look for radii or we look for diameter. In this case, we do have a diameter there, BD. So we know for diameter that a diameter subtends 90 degrees at the circumference, which is why I have marked angle DAB as 90 degrees there, because the diameter subtends 90 at the circumference, which is also called angle in a semicircle. We keep reading. FG is a tangent to the circle at A. So the word tangent there should bring tan chord theorem to your mind. So let's look for a few tan chord theorem if we can find any. Right, so angle GAD there, I've marked as equal to angle B. That is tan chord theorem. Your tangent is FG, your chord is AD, and AD subtends angle B at the circumference. So that's how your tan chord theorem works for that one. There's also another tan chord theorem that I've identified. It's angle FAB, which is equal to angle D, because the tangent is FG and the chord there is AB. That chord makes angle D at the circumference, so that's your tan chord theorem there. Okay, 4.1. Determine the equation of the circle in square form. Alright, so you go to your data sheet, you find your circle equation, which is x minus a all squared plus y minus b all squared is equal to r squared. Now, a and b are the center coordinates. So your center coordinates are -2 and 0. When you're putting that into this formula, you change the signs. So it becomes x plus 2 all squared plus y minus 0 all squared is equal to r squared. Now you need to work out what r is. R is the radius, and you can see on the diagram there I've drawn in a radius, but that joins points C and A, so the center to the circumference, which is a radius. Okay, you label it x1, y1, x2, y2 for points A and C. Put it into your distance formula and you'll get the distance of the radius, which is the square root of 13. Now that distance of the radius must go back into that square formula for the circle that we have above there. So your final answer there becomes x plus 2 all squared plus y squared is equal to root 13 all squared, which is 13. 4.2, find the coordinates of B. If we look at where B is on the diagram, we can see that B is a point that is on the circle, and it's a point on the circle that is actually on the y-axis. So that would make B the y-intercept of the circle. So for y-intercept, we know the rule is make x equal 0. So we take the circle equation, we make x 0, and we solve for y. So we'll end up with 0 plus 2 all squared plus y squared is equal to 13. 2 squared plus y squared equals 13, y squared equals 13 minus 4, y squared equals 9. Then y will equal to plus or minus the square root of 9. So y can be positive 3 or negative 3. But we look at the diagram, B is on the positive side for the y-axis. So the coordinates of B then needs to be 0 and positive 3. 4.3, determine the equation of the tangent FG in standard form. Okay, so a tangent is a straight line. So standard form they're looking for here is y is equal to mx plus c. So the equation of the tangent, y equals mx plus c, we go for m first. We try to solve for the gradient of the tangent first. Now, to solve for the gradient of the tangent, you need 2 points on the tangent, which we do not have, so we can't use the gradient formula for the tangent. There's not much else we do know about the tangent that we can use to find the gradient, so we look elsewhere. We do know that the radius is perpendicular to the tangent. Now the word perpendicular deals with gradient directly. So we're going to find the gradient of the radius first. We have 2 points on the radius. We have point C and we have point A. So to find the gradient, it's not going to be difficult. It's y2 minus y1 over x2 minus x1 using points A and C. And you get your gradient of the radius works out to be negative 3 over 2. Now we can use the gradient of the radius to get the gradient of the tangent. Because those two are perpendicular, all you do is you swap around that fraction that we got for the radius, the gradient of the radius. So instead of 3 over 2, it becomes now 2 over 3. The radius gradient was negative, so this one now will change to positive. So the gradient of the tangent is 2 over 3 now. So we put that into our y equals mx plus c equation for the tangent, so we'll end up with y is equal to 2 over 3x plus c. We substitute a point that's on the tangent, which is a, 0 and negative 3. So we'll have negative 3 is equal to 2 over 3 into 0 plus c. C works out to be negative 3. So our final answer for the gradient, the equation of the tangent FG is y is equal to 2 over 3x minus 3. 4.4, let's determine alpha. Alpha is on the x-axis at E there. It lies on the tangent FG. So we can just use m is equal to tan theta to find the equation for alpha. So in this case, it will be m is equal to tan of alpha. The gradient of the line that alpha is on, or that lies next to alpha, FG, we worked out before, the gradient there is 2 over 3. So 2 over 3 is equal to tan of alpha. Alpha will equal to tan inverse of 2 over 3, which is 33.69 degrees. 4.5, if they want us to determine theta now. Theta is there by D. Okay, so we start with angle CEG. That one is equal to alpha, 33.69 degrees, because that is vertically opposite to alpha. Okay, so EAB now. EAB is equal to 180 minus 90 degrees minus 33.69 degrees. That's sum of angles of triangle, that green triangle that I have drawn there. So we worked out angle A inside the green triangle is now 56.31 degrees. But angle A in the green triangle, which is EAB, that angle is actually equal to angle D, which is theta, because of tan chord theorem, if you can see it. Angle EAB equals to angle D, theta, because of tan chord theorem. That would make theta equal to 56.31 degrees. Okay, 4.6. Determine the area of triangle ABC. So triangle ABC is the blue triangle that I have drawn here. So the area of a triangle is half base times height, if you are lucky enough to have the height. In this case we do. So our base we'll take as AB. The length of AB is 6 units. If you remember the coordinates at B, there was 0 and 3. So the length of AB will be 6 units from A to B. Okay, and the height there is the blue line that I have drawn perpendicular to that base. And the coordinate there at C is -2 and 0. So the height there is 2 units. So the area of triangle ABC will be half base times height, which is half of 6 times 2, which is equal to 6 units.